guys, welcome to Unit 8, Lesson 2. This lesson will feel very similar to Unit 8, Lesson 1, where we looked at finding the volume of a cylinder. But in this lesson, we'll be looking at finding the volume of a cone. So remember, with volume, we're still filling something up. So we're still going to be measuring in cubic units. We cover with squares, so areas measured in square units. We fill with cubes, so volumes measured in cubic units. So if you think about cones and cylinders, they share one very important characteristic, and that is that they have a circular base. Excuse me, this is the formula to find the volume of a cone. And you'll notice that it looks very similar to the formula that we used in the previous lesson where we found the volume of a cylinder. You'll see that the big difference is we have this 1/3 right here. And everything else is the same. So the formula for finding the volume of a cone is 1/3 times the area of the base times the height. So that big B still means area of the base. Please don't forget that. That's hugely important in solving these correctly. So let's think about what that means. If when we found the volume of a cylinder, it was just area of the base times the height, and the only difference for volume of a cone is that we have 1/3 area of the base times the height, here's what that's telling us. If I have a cylinder and then a cone, and they have the exact same base, so a circular base with the same radius, and they have the exact same height, it would take 3 of those cones to fill the cylinder. So if I have a cone and a cylinder with the same base and same height, then the cone will hold 1/3 what the cylinder will hold. So that kind of makes the formula make a little bit more sense. So we're still going to do area of the base times the height, but then we're going to divide by 3. We're going to take 1/3 of that. So multiplying by 1/3 and dividing by 3, same thing. So a very similar formula that we're working with here with finding the volume of a cone. So let's break this down step by step. So remember that the formula for the area of a circle, so we have area equals pi times a radius squared. That's how I find the area of a circle. So for this example, if in step 1 we want to square the radius, well, it gave us the diameter. Okay, in this case, the diameter was 13. So the radius would be half of that, which would be 6.5. So the radius is 6.5. And so if I square that, so 6.5 times itself, I get 42.25. So I squared the radius. So that takes care of the r squared, or radius squared part. Now I want to multiply that times pi, so times 3.14. And that gets me 132 and 665 thousandths. So I've done the radius squared times pi. So now I have big B. That's my area of the base. Now we're going to multiply that by the height, which is that 18. That's how tall the cone is. So I'll do that times 18, and that gives me 2,387 and 97 hundredths. So if this were a cylinder, we would stop there because we've done area of the base times the height, or area of the base, and then times the height. Now we're going to divide that by 3 because for a cone, our formula says 1/3 area of the base times the height. So I'll just divide that by 3, and we get 795 and 99 hundredths, and that would be cubic centimeters. So it's still area of the base times the height, but then divide by 3. Okay, let's look at this example. What is the difference between the volume of the cylinder and the volume of the cone? Well, for the cone, volume is 1/3 area of the base times the height. So in this case, that would be 1/3. Now for area of the base, we're going to do pi times radius squared because our base is a circle. And we can see that I have a diameter of 4, which means I have a radius of 2. So radius squared, and then times the height. There's my height right there, and it's 6. So times 6. So 1/3 of 3.14. 2 squared is 4, and then times 6. So what I would do is go ahead and do 3.14 times 4 and then times 6, and then divide by 3. You can divide by 3 anywhere in the process that you want. Since we get to use the calculator, I would just save the dividing by 3 until the end, but you could do it anywhere along the process that you want. And that would be cubic inches. Now, because of what we know about the formula, we should find out that the volume for our cylinder is 3 times greater. So it should be whatever 25.12 times 3 is, but we'll see. So for a cylinder, it's just area of the base times the height. There's no third. So we have pi times the radius squared. So again, here's our diameter right there at 4. So the radius would be 2, and that's squared. And then times the height. We have a height right here of 6. So 3.14 times 2 squared, which is 4, times 6. So it looks just like the other one, except we don't have to take a third. So 3.14 times 4, and then times 6. And we get 75 and 3600 cubic inches. Now this said, what is the difference between the two? So we'll subtract those. So 75 and 36 hundredths minus 25 and 12 hundredths. And so the difference between the two is 50 and 24 hundredths cubic inches. So the cylinder holds 3 times what the cone holds. And that gave us a difference of 50 and 24 hundredths cubic inches. Okay, let's find the volume of this cone. So again, we'll just use the formula. So volume equals 1/3 area of the base times the height. So 1/3, we've got a circular base. So big B is going to be pi times radius squared. So pi times, it actually is giving us the diameter right here. So if the diameter is 2, that means the radius would be 1. So 1 squared times the height of 6. So 1/3 of 3.14 times 1 squared. Well, 1 times 1 is just 1. And then times 6. So I'm going to do 3.14 times 1, and then times 6. So that's 1/3 of 18.84. And so I'll just divide 18.84 by 3. And we get 6 and 28 hundredths, and that would be cubic inches. So the volume of that cone is 6.28 cubic inches. In other words, if I had a bunch of cubes that measured 1 inch on every side, it would take a little more than 6 of those cubes to fill that cone. And that is it for Unit 8, Lesson 2, volume of a cone. Again, the formula looks a whole lot like volume of a cylinder. The only difference is we have to divide by 3. We've got to take 1/3 of area of the base times the height. If you want to see some more examples, I'm happy to work through those with you. If you're ready for me to open the skill check, let me know, and I'll be happy to do that. Have a great day, and see you later.